Rhombus. What's a rhombus? All right, here we go. Quadrilateral in which all four sides have the same length. All right. Quadrilateral, all four sides have. How does that? All right, I'll just draw the picture. We'll figure out later how that helps us. All right, quadrilateral, all four sides are the same length, so it's going to kind of look like a diamond, like this. And I'm going to go ahead and label it so we can talk about it. A, B, C, D. And one of the diagonals has length 30. That one be the one that's length 30. All four sides have the same length. Let's go ahead and write those 25s in as well. And we need to find the area of this. Well, ABC is an isosceles triangle, and I know how to find the area of an isosceles triangle. Usually draw the altitude from the vertex between the two equal sides. Draw that altitude, and that splits an isosceles triangle into two identical right triangles. Well, that means it must hit the midpoint of AC. It must split AC into two equal pieces. And the whole AC is 30, so each piece must be 15. Now I have a right triangle, and I can find the altitude length here. Use a little Pythagorean theorem. We have bm squared plus 15 squared equals 25 squared. So bm squared plus 225 equals 625. bm squared is 400, which means bm is 20. Oh, of course it's 20. These are 3, 4, 5 triangles. That's 3 times 5. The hypotenuse is 5 times 5. That means the other leg has to be 4 times 5 is 20. So now we can find the area of ABC. And then we can do the same thing over here for triangle ADC. Start off, we draw the altitude, and it has to hit the midpoint of AC as well. So the altitude from D has to hit the same point on AC that the altitude from B hits. And of course, these are both right angles. So these angles add up. 90 plus 90 is 180. This is a straight line. And that tells us that this is the diagonal. This is the diagonal of the rhombus, just like this is. Now, of course, these two right triangles are identical to these two right triangles. Over here, this is an isosceles triangle as well. Also, we can see that hypotenuse is 25, one leg is 15. We already solved that problem. This is 20. So now we see that the diagonals of a rhombus are perpendicular, and they cut each other in half. They bisect each other. Now we can answer the original problem here. We can find the area. We've got our 4 right triangles, so our total area is 4 times the area of one of these right triangles. These are all identical. Each triangle has area 20 times 15 over 2. 20 divided by 2 is 10. 10 times 4 is 40. 40 times 15 is 600. We've got our answer. But much more important than this answer, we have a better way to look at a rhombus than just 4 equal sides. A rhombus is 4 identical right triangles put together like this. The diagonals are perpendicular to each other. This turns out to be a really good way to think about a rhombus. Here we've got a rhombus. Rhombus means all the sides are equal. And we draw in the diagonals. And it cuts the rhombus into 4 identical right triangles. Means these two diagonals bisect each other, they cut each other in half. So these identical right triangles have legs of length x over 2 and y over 2. So we can find the area of the rhombus. The area is just 4 times the area of one of these little right triangles. Area of one of these little right triangles is 1/2 the product of the legs. Legs are x over 2 and y over 2. 4 times 1/2 is 2. 2 times x over 2 is just x. X times y over 2 is just xy over 2. So the area of a rhombus is 1/2 the product of its diagonals. Hey, wait a second. There's an even slicker way to see this. Check this out. I'm going to do a little outside the box thinking. We go outside the rhombus like this. And if I had drawn that better, it would really look like a rectangle, but I want you to think rectangle here. I'm building a rectangle around my rhombus, and the sides of this rectangle are equal in length to the diagonals of the rhombus. So this area, this entire rectangle, is x times y. Now take a look at the rhombus. Each of these little rectangles in each of the corners, half of the little rectangle is inside the rhombus, half of the little rectangle is outside the rhombus. So the area of the rhombus here has to be half of the entire rectangle, because each of these little pieces, half of it is inside the rhombus and half of it is outside the rhombus. Area of the entire rectangle, of course, is x times y. Rhombus is half the rectangle. Rhombus is xy over 2. But wait, there's more. Once again, we have a rhombus. We have a rhombus, that means the sides are equal. And as we just saw, we draw the diagonals of a rhombus, and it cuts the rhombus into 4 identical right triangles. And because these two are identical, these two angles are equal. Because these two angles are equal, these two sides are parallel. And in the same way, these two angles are also equal. That tells us these two sides are parallel. These two opposite sides are parallel. These two opposite sides are parallel. We have a special name for that. We call it a parallelogram. Parallelogram, all that means is opposite sides are parallel. And what we just discovered is that every single rhombus is a parallelogram. Now this street doesn't run the other direction. Not every parallelogram is a rhombus. Right here we've got a parallelogram. Opposite sides are parallel. This obviously is not a rhombus. This side does not equal that side. All right, let's recap. We went through a lot there. Let's recap. We'll start right up here. A rhombus. All 4 sides are equal. And we can think of a rhombus as 4 identical right triangles pushed together because the diagonals of a rhombus are perpendicular and they bisect each other. We can use that to see that the area of a rhombus is half the product of its diagonals. And then we discovered that every single rhombus is a parallelogram, which means the opposite sides are parallel. But not every parallelogram is a rhombus.